Hey geometry students, welcome to our first lesson in topic 10. I apologize I cannot be there with you guys today and tomorrow. This is a tough topic, and the first lesson, look at how much vocab we have, holy moly. It's going to be a lot today and tomorrow, but here's the thing is I trust you guys to try your best. The cool thing about videos, although I'm sad I can't be there with you guys, is that if you are understanding something, you can pause at any time, you can rewind, you can re-listen to things, whereas if I'm teaching in class, it can be hard to do that sometimes. So you're welcome to pause anytime. You can rewatch the videos if you would like to, rewatch an example. You can also speed things up if you're feeling good about the concepts. You can go through a bit quicker. It's up to you to kind of decide how you're feeling about the lesson. So this vocab, I'm not going to talk about a ton because these words are going to come up more in our next examples. So you're welcome to pause right now really quick and just write everything down. And yes, it'll take you a few minutes, so take your time. Go ahead and pause right now, write it all down, and then I'm just going to talk about a few important things before we start example 1. All right, guys, our big focus in topic 10 is circles. And in lesson 1 specifically, we're looking at what we call arcs and sectors. We'll learn what those are as we try a few examples. Kind of the big things to know, our big focus is on these arcs. These arcs will help us find out things about sectors. Now, an arc in a circle is kind of like a curve. So this is an arc. We have lots of arcs in our circles. Sometimes we have an arc that forms a semicircle, and you guys know that measures 180 degrees. Sometimes we have arcs that are smaller than 180 degrees. We call those minor arcs. And sometimes we have arcs that are bigger than 180 degrees. We call those major arcs. Now, with these arcs, we can find the degree measure of the arcs, but we also can find their length. So what we're going to see today is we're really going to be doing a lot with the measure of arcs. And we're going to be finding the length of arcs. And what I really want us to try to work on is seeing that those are not the same thing. If I want to find an arc measure, I'm looking for the degree that is formed at that arc. If I'm looking for the length, I'm finding the actual measurement, the actual length of that arc. If I were to take that arc and kind of push it into a straight line, that's what the length is actually finding, whereas measure is a degree. We'll see that in our first few examples. We have some formulas for finding the actual length of an arc. That's a little bit more complicated than finding the measure. We are almost always going to be in degrees, but we might see some examples later on today where we are going to be switching our modes to radians, and we will see that in one of our future examples. Last thing, a sector, we also have an equation for finding the area of a sector. A sector is like a section in a circle. So, for example, I just drew these two sketches right here. This is an example of a sector. We have two radii and an arc, and together those form a sector, and we can find the area of those. It's kind of tricky because it doesn't form a perfect triangle, so we have to use a specific formula in order to find that. Same thing down here. This is a sector, and actually I did not draw that perfectly. Let's redraw that. It's not a triangle because it includes an arc. Now, if we are finding the area of a segment, so a segment is that part inside of the sector that makes it actually not form a perfect triangle. So the segment is what is highlighted in purple here, what I outlined in green. This segment, how we would find that is we would find the area of the entire sector. We would then find the area of the triangle formed, and then we can subtract those together to find what's left over, which we like to call that a segment. All right, let's go ahead and start with example 1. Just an introduction into our circles and our arc measures and central angles. All right, so in our circle here, let's just take a gander at what we're given. So we would call this circle P. We typically name circles by their center. I see that we have a central angle, an angle formed by the center, 95 degrees. And we can see that we have some labeled arcs. So there's arc AB, there's arc, we could call this one BCA. We could also go counterclockwise, call that arc ACB. But those are our main arcs that we have. Now, we have a minor arc and we have a major arc, so just some practice with that. This is a minor arc just because it is less than 180 degrees. We'll see why in just a second. And this guy over here, ACB, is a major arc because it is more than a semicircle. How can I find the exact arc measures? Those are always based off the central angle. So this central angle opens up to AB. That is the intercepted arc. So whatever the central angle measures is what the arc measure is. So if the central angle is 95, the arc measure is also 95 degrees. Not too bad. Now to find the measure of the major arc, ACB, we need to know the central angle, that angle that opens up to this. So we don't know what that is right away, but we do know the measure of a full circle is 360. So we're going to do 360 minus 95 degrees, and what we see is that the other central angle here is 265. Together, those central angles should always make a 360. All right, so if that is my central angle, the intercepted arc that angle opens up to is ACB, and those must measure the same thing every single time. The central angle is always the same measure as the arc measure. All right, so now we're going to introduce a little bit more with arc length. Length is very different. Measure is what we just did. Measure is with our central angle, it's a degree, whereas the length is actually finding the units of the arc and how long it measures, the distance of that length. All right, so how are we going to do that? Well, we have a formula, and here is our formula. S stands for the arc length. I don't really know where the S came from, honestly. You can just call this arc length if you would like. You can call it A, L, whatever you want. But here's how we find the arc length. We are going to take circumference, right? The circumference of a circle, the distance all around the circle, and we're going to times it by just the part of the arc that we are focusing on. N right here, N stands for the arc measure of that angle that we're trying to find the length of, or what we just learned is that's the same thing as the central angle. So we are going to try to find the arc length of XZ. In order to find the length, I need to know the arc measure. That is the N value. And since the central angle is 115, the arc measure is also 115. So that is the number that's going to go in for N. N is, again, either option 1, the central angle, or the arc measure. Those will always be the same number. And then we're going to times that by circumference. Essentially, we're taking the portion of the circle and we're finding just the length of that arc. What we also need besides N, we also need our radius, and they will always tell us what that is. The radius is 6, so we're going to go ahead and plug that in for R. All right, we are actually going to do some pretty simple simplifying. We're not going to simplify this all the way down. Here's what we're going to do. We're going to first start by just multiplying those 3 together. And we're actually not even going to multiply the pi. I just want us to do 2 times 6. And when we do, we get 12. And we're just going to leave pi on the end. So we're just simplifying that first to get 12 pi. And here's what we have now. So we have 115 over 360 times by 12 pi over 1. We're just going to put that over 1 for now so that we can times these fractions a little bit easier. All right, let's times the top numbers times the bottom numbers. On top, we're still just leaving pi how it is. I actually don't want us to times by pi because you guys know we're going to get a crazy number. So I'm just timesing 12 and 115 on top, and I get 1380. And then the pi is just going to hang out on the end still. And then on bottom, we get 360 times 1. This right here is how we are basically going to leave our answer. I might say that the only further simplifying I want us to do, I know that this fraction here we absolutely could simplify, but to make our lives easier, let's just do this. If there's a 0 on top and a 0 on bottom, let's simplify those out. Otherwise, that's the furthest that we are going to go. We could probably spend all day simplifying this fraction, but right now that's not my focus. I want us to learn about measures and lengths of arcs, and simplifying the fraction is not my main concern. So this right here is how we're going to leave our answer. We're just leaving pi in the answer as it is. Okay, let's go ahead and try one more, and then we'll pause the video for example number 4. All right, so it says, what is the length of arc AD? Express the answer in terms of pi. In terms of pi is exactly what we just did. That just means keep pi in your final answer. All right, let's go ahead and find arc AD. I'm going to highlight it. So arc AD is right here. Now, a good question would be, Ms. Farr, why can't it also be like this arc right here? Now, typically, if we were to cross through other letters, like, for example, we would cross through B, C, and D, we would have to specify that in our arc. We don't necessarily have to specify every letter, but the reason why we know it's the purple arc is because this would have to be something like arc ABD or ACD. We would need to include more letters to show for sure which arc it is. Moral of the story, here's our arc that we're focused on. If I'm going to find the arc length, we need to know the central angle or the arc measure that opens up to that arc, and we need to know the radius of the circle. So let's see. I do believe that we have a radius right there. That is our R value. I'm going to go ahead and plug that in first. All that we're missing now is our central angle or the arc measure of AD. So if I look at the arc measure, they don't give me an angle measure here and they don't tell me a central angle. But it does look like we're given enough information with our other central angles to find out what our arc measure is that we need. So we're going to do 360 and subtract out those other three angle measures. And it looks like when we do, we're left with 140. So if I add up all four of those central angles now, they should always add up to a full circle, 360. If that is the central angle, whatever arc it opens up to is the arc measure, 140 degrees for both of those. So we're going to need to know that in order to find the arc length. So we know the arc measure and the central angle that we need is 140. That is what we plug in for n. We plugged in our radius, we plugged in our n value, now we're ready to simplify. Let's start here. 2 times 4 is 8, and then pi is still just going to hang out on the end. So here's what we're looking at now. 140 over 360. Times that by 8 pi over 1. And really all we're going to do, you guys, is we're just going to times the numbers on top. We're going to keep pi. So just timesing those two numbers in my calculator. 140 times 8, I am getting 1,120 pi. And on bottom, just 360. We could simplify this fraction all day. The only simplifying I want us to do is if we can get rid of zeros on top and bottom, let's go ahead and cancel those out, and we'll leave our answer just like that. So 112 pi on top over 36. That is the length of arc AD. Length of AD. And we'll do a little arc over top to show our notation.